Hello, it's Chill Maths. I'm starting the stream, this time for real. Here we are on Sunday afternoon at time of recording. We've got a Chill Maths stream, which is where we hang out and maybe solve some maths problems together. I've seen some good maths problems recently, so we're sort of working through those as content on the show. And I'm a little bit late because all these buttons I have to press. Have I pressed the unmute button? Yes, I have, but the microphone's over there, so give me 2 seconds. There we go. Distracted myself by typing notes about what I was going to do, and then I realised it was time for me to start doing it. So here we are, more or less. You can do a grid of points in one line in Desmos, says Maths222. You see, that's the sort of thing that gets my attention on Chill Maths. Go on then, hit us with the one-liner. I often want to do a grid of points, and then maybe access them later, or do something for each of them, or draw lots of little arrows, or sketch lots of points. Mary Herb and Rice Cooker Man are here, and I saw yes, Maths222 at the top. I sort of thought that complex numbers would help us make things better in Desmos. If you weren't here last week, or if you haven't seen yet, Desmos does complex numbers now. It's very good. Let's just have a quick look at that, because wow, it's really nice. Just a quick reminder for people for whom this is new. You go in settings, you switch on complex mode, and then you can type all sorts of stuff, and it knows how to move points around in the Argand diagram and calculate square roots of complex numbers and stuff. Oh wait, what? Maths222, that is a devastatingly straightforward expression in some sense. Devastating for me. How long have I been able to do this? 4x in, and you've got some square brackets around. Wait. Can I do coordinates? That's greedy, isn't it? Ooh, 4 is a keyword. 4 is a keyword. But then you do j equals. Oh, it's been there for years. Oh, that is annoying. Okay, well, annoying in a sort of professional sense, that you can just do 4 as a keyword. Well, still good knowledge, isn't it? And now I've messed up my brackets. There we go. With a second, with a comma. Grids. Thank you. Good to know. See, I'm learning. Sometimes in my life I do maths things, and I'm supposed to be teaching. Like on Monday I'm supposed to be teaching some first years again, just a small group of first years, but supposed to be teaching. Sometimes I do math stuff and I'm learning. Here we are, look at this. Grids of points. Can I move them around? That'd be nice, wouldn't it? If I had a kind of control point on them. Won't let me do it like that. It will let me do this. Don't know, it just feels like moving them around might be fun. There you go, and then I can drag it around. That could be good. Okay. Well, immediately I want to do a kind of complex number thing on this, right? We've had grids before where sometimes it's on stream. Did I see Mandelbrot? Yeah, we put it on the show, didn't we? We did the right at the end. We did the with all the nested x plus iys for this Mandelbrot set thing. Put it in here. Good, right. I'm still very taken with these square roots. Kind of want to do, what do I want to do? So I kind of want to do multiples of a complex number. Let me hit this like this, and then do something like z times a plus bi. Or let's see if I can remember the syntax. A is 1, 2, 3, and b is 1, 2, 3, but you don't have the 1, because that gives me a kind of grid that's defined based on the complex number, like that. So why is it off by 1? Presumably I want to include b as 0. to not do the rotation or something. There we go. That gives me a grid that kind of scales around so that it's always got right angles, and includes the origin. If I put this 0 in as well. There we go. It's a nice lattice. I should put negative numbers in here as well. Can I define this list separately? That would be good. We're doing Desmos today. Desmos has a kind of ticker in it. I've seen people do the thing where a metronome's going, and it's every second it does the same. Applies a function again. So you can do recursion live if you're interested. Sorry, I'm sort of talking to messages. I just got distracted by my own chat message. Yeah, sorry, I want to sort of define that list, don't I? So that I can save myself the bother. Can I put it in here? Can it be defined? Oh, I think we're okay. I think we're good. That's more tidy. Define this kind of list, and then show me that in multiples and in multiples of z times I. So this one is z, that one is z times I, and then show me linear combinations of those. You can have some fun with that, I think. Sort of right angles, lots of squares, multiples. I've needed this before to demonstrate the Euclidean algorithm for complex numbers, which is this division algorithm thing where you want to write, given two complex numbers a and b, you want to write a as a multiple of b plus some remainder, and in the integers it's kind of clear how you do remainders. For complex numbers it's not obvious how you do remainders because you live on the Argand diagram, but there's a way to make it work. Yeah, okay, good, right. Yeah, do link us to cool Desmos stuff as we go along. That's fine. I don't mind being distracted by Desmos stuff as we go forwards. But shall I tell you a maths problem that I've seen? This is really good. I don't know if I've seen it before, but I saw it this week, and it seemed like the sort of thing that you might like as well. So I saw this on Finite Group. Finite Group do a live stream. Finite Group consists of 4 people: Katie Steckles, Peter Owlett, Alien, and Matthew Scroggs. Why did I do that in no particular order? And they did a live stream celebrating their birthday with a problem in it about birthday paradox. They've been doing their live stream for a whole year, so they did this thing on the birthday paradox, where they had a version of it with twins, which I thought was really good. Here's how the birthday paradox with twins works. Normal birthday paradox first. So normal birthday paradox is that thing about 23 people sharing a birthday. Not entirely like that, right? But sort of 23 people sharing a birthday. You have people, and you keep adding people until you have found 2 people with the same birthday. And the question is, how many people do you need to have a 50% chance that 2 of them have the same birthday? How many people do you need before there's a 50% chance or something? 2 of them have the same birthday, which is fair enough. And sort of probability statistics, as chat, Rice Cooker Man in here is talking about stats. The idea is, I suppose, that you can just work out the probability that they all have different birthdays and do 1 minus that. So work out probability of the alternative with different birthdays. And do 1 minus that, which is a fairly standard probability trick, I think. So you see things like with one person, there is probability 1 that they will have different birthdays. With 2 people, the next person arrives at the party or whatever. It's sort of 364 divided by 365 that they have a different birthday to everyone previously at the party. New person arrives, and their probability of having the probability that they have a different birthday from everyone already at the party is 363 over 365 because there's 2 days to avoid. And then you can sort of keep going. And the question is, times what is about 0.5? And the answer is that you only need 23 terms like this before the probability gets down to 0.5, which is a bit surprising because 23 is not very much. I think we did, I feel like this is the sort of thing that I've talked about before in my life. Maybe you've seen other people talking about it as well. I wrote some terrible Python code. I'm really bad because I don't speak Python. I'm trying to learn a tiny bit of Python. This is where I've got to say what I want is to go through people arriving at the party, including, because of Python, including the 0th person to arrive at the party. Fine. And then I want it to multiply. So take this probability that it's tracking and multiply 365 take I over 365. Fair enough, right? I think if I run this, ignore the bit where it's doing hello world, it says 22, which is not 23 because of out by one errors on my behalf because I'm coming from a different place. So this says 22, but that means something like I've just multiplied 365 minus 22 as the last term in here. Yeah, so I is 0 for the first iteration. I is 0 means that there's 1 person at the party. Their probability is 365 minus 0 divided by 365. It's certainly not happening. And then the second person arrives. I is now the number 1. And you get 364 over 365. I think I'm going to print I plus 1 to say how many people are at the party, not how many. What was the largest thing we subtracted from 365 or something? And now there's 23, of course, because I've just told it to do this. Yeah, so I is 0 early on. Okay. Problem that I've seen before, I think. So here, this is the second person, but it's 365 minus 1. And this is apparently this thing stops when you get to 365 minus 22 over 365, which is the 23rd term, because we start at 365 minus 0 up here. Numbers, right? Counting is hard if you need to be exactly right or something. There are other versions of this, and the one that I want to talk about is the twin version. And this version, at the moment, what if they're all twins? Sort of doesn't matter. It doesn't mean anything to say that they're twins. I mean, what if they're all twins with each other? Doesn't make sense because there's 23 of them rather than 2 of them. But what if all of them are twins? The way to make this make sense is something like, and their twins are also here, and there are only like in the finite group live stream they said 500, but I'm going to put n people here total. So the way to make the twins thing interesting is to say the twins are here, so people have arrived in pairs of twins, and there are only n people here total. Right, Mary's had an ad and it's now maybe back up to reality. We'll find out. You can see your own chat messages on the screen if you want to sync up with reality. I think we're pretty low latency. I don't know. I just looked at myself on screen and I'm still pointing at Mary's chat message, so swings and roundabouts. Hello, Syria Hackney. Welcome to chat. First time chat. Change birthday to birthday. Is that a comment about my handwriting? Right, we've all got delays. We've all got things going on. Oh, birth hour, maybe. Birth HR out of 24, maybe. Whatever. Okay. You can do this more. Yeah, the obvious tweak is you change number 365 because the number 365 in this Python code, the number 365 feels pretty arbitrary. So you can sort of play this other game where you write something like. It's trying to teach me proper style, right? So you can put that in here and here and here, and it should still give me 23. But possibly if I change this to sort of some larger number, then we get a different number of people we need to have at the party because there's many options or categories that they might fall in. There is some intuition for this, but there we go. Hello, Phobos Stream. Welcome to the show. I am ill-advisedly trying to do some code. Phobos Stream, I know, does actual computer science live on Twitch. So if you want to see actual professionals have a go at writing code, then Phobos Stream is the person for you. I'm just learning Python. Hooray! That's the one that people learn, isn't it? That's the one. If somebody says I'm learning, then the next thing they say is quite likely to be Python. You can predict it with some sort of language model. Right, okay, and I have to not say that one because of the theory of those things. We will be fine. Buckets. I'm going to say buckets. Good. I read at one point there's some intuition for this, that if you change this number for how many buckets there are that people might belong to, sort of, I don't know, some attribute like eye colour, and there's many eye colours, then something I read once is that your intuition should be that it's like the square root of this number. Let's see if I can verify that. So I think this should be about 100, roughly speaking. But then if I put 2 more zeros on it, it should go up to about 1,000. Yeah, okay. And then 2 more, it goes up to about 10,000. Sure, so there's kind of scaling law for how this thing behaves, that number on screen also seems to be tending to some sort of constant, maybe 11% of the square root of whatever. Anyway, there's some constant out the front, which I feel like I've read somewhere. Anyway, there's some intuition for what's going on here. It's like subtracts 2 zeros on here, it only divides the answer, which is appearing at the bottom of the screen, by 1 order of magnitude. That's going to go wrong down here. I sort of want to do a plot there because I think the ratio of the small number to the square root of the large number might be quite predictable. Could play the game there. I don't know how to do a plot in Python, and I don't think that me learning to do a plot in Python would be that interesting as content. So we'll maybe come back to that as a separate challenge. But it's sort of, for the standard birthday problem, the answer seems to be about 1.1 times the square root of this, which is not bad. Let's do a kind of separate line down here to print out our rough intuition of it being 1.1 times. Now, it's not going to know square roots, is it? It doesn't have built-in square root. This is the thing that I have to learn about Python. So this will throw an error message because it doesn't know what square roots are. But if I import math as math or something up here, then I can put math full stop in here. I have to remember that square rooting is a kind of math concept. So then it'll tell me something like this. And we can sort of think about how that lines up to be, on one hand, not a whole number. Yeah. If we import it as maths, that is a good point. We have maths in chat. There we go. Oh, now it's going to complain to me, and I'm going to have to remember that every single time. Sort of British penalty. Writing slightly longer code. Am I allowed to just do import math? Yeah, I sort of wanted to, let's do the import matplotlib sort of thing. I'm going to have to learn, I'm going to have to learn so many things. So to do a sensible plot here, I would want to explore the number of days varying across the x-axis, possibly on some sort of log plot, and I would like to see that output, which I guess I could wrap this in a function or something, but I'd like to see the output tending towards something like 1.1. Hello, Mimachine Rex. You can do 0.5. That would help me avoid the maths thing. So you do powers of 0.5 built in, but it can't do square roots. Or doesn't know about square roots. Okay, fine. I'm just saying, like, in Windows, the scientific calculator has the concept of a square root. That I just feel like if this has got a built-in square root button, then I don't know. Python. It's many things for many people. It's not fair for me to compare it to such incredible programming software as the default Windows calculator. Right. Oh dear, I'm going to get flack in chat now, aren't I? Yes. Okay. Okay, the direction I want to take this instead is to think about the twin version, which I met maybe for the first time this week. If I've seen it before, then I forgot it. So it's the experience of seeing something new, at least. Everyone here is a twin. So once somebody's arrived at the party, there's kind of the second person might be a twin. And then, confusingly, even if they're not a twin, might share a birthday. So, as people arrive, they might just be the twin of one of the people we've already got, and even if they're not, then they might still share a birthday with someone at the party. So far, I'm constructing a party, I suppose, but this time I have to put a kind of size of people. Maybe I won't say they're here. I have to put a size on the kind of size on the collection of people to work out this probability that they might be a twin. So a new person arrives. With one person you have this sort of 1. But then just on the second person arriving, you have this sort of 1 chance in a high number, 1 in n-1, that they are the twin of this person. There were n people available to come to the party or something. And what are the chances that the first 2 people to turn up are twins? And it's not quite right, because twins might be more likely to travel together. But whatever, here we are. Even if they're not twins, they might have the same birthday as one of the people at the party. So that's this person. And then I've got the next person. There are 2 chances, assuming that no one shares a birthday and that therefore that they're not twins. There are 2 chances that they might be a twin now. 363 plus 365. That they have a different birthday to both the people here. So this is my first person. And this is like my second person, and this is my third person. So sort of in the limit that there's a huge number of people available, you never find anyone's twin. So these terms are all 0. So I've done something wrong, haven't I? Oh yeah, to be not a twin is to be one of the other people. Sorry, this should be the other way around, shouldn't it? To be not a twin is to be one of the other people. There are n-2 other people in the universe, of whom only 1 is the twin of... No, what am I talking about? What am I talking about? So I want them to be not a twin. Here we go. Oh my goodness. Group of twins. 4 different twins in 2 pairs, or 4 people who had twins? Sorry, Marion Chat's doing a great version of this problem where instead of looking for shared birthdays at all, you just look for other twins out in the world. How many elevators do you have to get in before eventually you get in an elevator with 4 twins in? That is pretty crazy. Oh, people who had twins. Right, okay. There you go. In my world, everyone has a twin in this problem, I suppose. Yeah, okay. So out of all of the next people who might have walked in the door now, one possible person would be like, oh my goodness, that's the twin of this person. Whereas here, and this is greater than 1. I've got to fix this. It's greater than 1. It's out of the n-1 people available, one of them is the twin, and n-2 of them are not. There's probability. Oh, it's got me. n-2 people who are not twins. And in here, is it going to be n-3 or something? There are 2 people who's going to be n-4 because there are 2 people out there in the world somewhere who are twins of the 2 people at my party out of the n-2. So there are n-4 people who are not. This fraction's going to 0 at some rate as well. Sure, so one way to think about this is this term is 1 minus the chance you share a birthday with someone at the party being not twins. Hey, thanks for the follow. Who's just followed? I was 1. And shout out to Ayushk0013 as well, who followed during the week. I am 1. There. I'm going to pass it like that, I think. I am 1. You can let me know in chat if I've put the spaces in the wrong places. Good. We're trying to get to, how many? 315 followers, at which point that will buy us enough time to construct the Wikipedia page for the number 315. The Wikipedia page for the number 315 doesn't currently exist. So I think that's a solid kind of target for this live stream's sort of legacy or contribution to the sum of human knowledge, is to make sure that by the time we get there, that there is a Wikipedia page. I'm not saying we go on the Wikipedia page. I'm not saying that that's the thing. That's not the thing that makes it notable. That's why we've picked that number. 314 does have a Wikipedia page, which doesn't seem right to me. 315. Yeah, that's where we're at. Well, it's not. That's where we're going. Like a natural. I could do this. Talking about subscribers, multiplying numbers together. Easy peasy. Right, okay. In the limit that n is large, which is a useful limit to think about because it forced me to think about whether these probabilities were between 0 and 1 and which number they were close to. These things are both close. This thing is close to 1. This thing is sort of still close to 1. In the sort of limit that there are a huge number of people available, you're never going to find any of the twins because they're just out there somewhere. So even if everyone's twins, if you're picking random people out of the world, you're never going to find the twins because they're even rarer than birthdays. Is kind of the idea here. This number n is sort of doing a separate race. You see these brackets are going to 0 and those ones are going to 0. Anyway, let's put that in Python and see what happens. This does involve slightly messing up the code that we've already got. So we're going to put a number in here. I'm going to go for 1000, I think. And I'm going to write myself a note to say that this is people available 2n twins or something. N all twins or something. There we go. That's good. So then in here, I'm going to refactor this slightly to be a large bracket. Oh, it doesn't like that. And I'm going to, I think, pull out the 1 minus. Oh, I don't really know what's better. Yeah, I think it's better to only say, this thing once. So I'm going to pull that out. 1 minus I over n days. Oh yeah, that's nice, look. That's nice. Let's just check it still works. Still working, good. We're going to hide this because I think that's going to stop being true. And we're going to put in this new term to say you also have to avoid being one of the twins. Quick look back at my charts. What have I got? This should go like subtract 1, subtract 2 over n minus... Oh, the denominator's changing though. The denominator's changing as we go along. That's fun. Because the number of available people is changing. Cool, okay. So this is going to be 1 minus I over n minus I or something. Back in we go. 1 minus I over n days minus I. So it's a slightly different process, isn't it? Slightly different process. And I don't want n days, I want n people in that one. Cool, okay. So this term again is counting the probability. So you need to be not a twin and then also different day of the year. Yeah. If I put it in Desmos, I can do a graph. Fair enough. That's brought it down to 20, which seems about right. But it's slightly more likely. So this thousand people thing means that this 1,000 people thing says maybe if you've got maybe if you get up to about the square root of 1,000, then roughly speaking, then you might have picked up 2 of the twins, and that's taking much longer, so it's not making much difference. But if you bring this down to 500 or something, then that starts to really reduce the time that it takes, maybe not that much, to take over and say how long does it take. There's a kind of competing thing to say, is it happening because you found a pair of twins who shared a birthday, or is it happening because you found 2 people who just happen to have the same birthday? So if I make the number of people available really small, then you don't have to pick that many of them. So with 5 pairs of twins, this is saying that I should only have to pick 4 people before probably I found two of a pair of twins, which is kind of interesting. Whereas if I make this very large, then it's 23, because the twins thing never happens, and we're just waiting for the birthday thing to happen. So there's this trade-off where this can start having an effect when, I think it might start having an effect when half of that number, when the number of families of twins is similar to the number of days, because partly I'm thinking of the twin thing as a kind of bucket situation as well. It means that the terms in the fraction are going at roughly the same rate. Okay, let's put this at about 300 because that's an interesting number. Then you get down to about 16. Yeah, cool. Okay, would like a graph of this. Let's see if we can either rebuild this in Desmos or get MATLAB, get whatever this is, Python to do, get Python to do some sort of chart, which is going to be easier. I don't really know how you do the stop condition in Desmos. You're asking Desmos to do this thing where it keeps multiplying, and I'm returning the value of I, not the value of the function, which is 0.5-ish. Kind of want another variable in there somehow. Shall I look at your Mandelbrot recursion instead? Let's do that. Seems like a nice thing to stare at while I think about what to do in either Desmos or something. This is amazing. This is insane. I can't actually believe this. I assume this is some sort of prank. Has anybody else clicked on this link that Maths222 has been putting in chat? I've done it for you. It looks like this. That's just the Mandelbrot set. I don't. That's ridiculous. So, Maths222 in chat has defined a function, which takes a point called C in a complex plane, and starting iteration at 1. Oh, what is this? It's on the Discord. I should check the Discord more. Number of iterations, right? Or something? Take the previous one and square it. Oh, so it's an iterative thing, right? And it's doing 97 iterations. So every time, if A is if 1 is 0, then if A is 1, return 0. Otherwise, it's a recursion thing. Look at the previous one. You let it subtract 1 from the number 97 and then go back. And you've told it to do it with this with complex numbers. This, if I make that 2 instead, is that fun? Sort of all right. It's not the same. So you've got the condition on it stopping. Pretty similar. Oh, it's crispy around the outsides. Oh, it's having a go though. It's having a go. It's having a go. It's not going to refine fine detail as it's given us that error message. This is so good. It's really trying. Okay, so the brackets are how Desmos apparently does this if statement thing. Oh, so we can do something like that for a birthday problem, can't we? They are a bit deep fried. Yeah, there we go. There's the error message I thought we would get. Brilliant work. Love it. I'm making it do twice as much as it needs to. Let's get rid of that. My computer is now on fire. No, it's having a go. There we go. Excellent stuff. I'm really surprised that just works in Desmos. That's fantastic. Ah, brilliant. Okay, right. Yeah, we can do something like this for the birthday problem, can't we? Let's have a go at that. So we'll do some sort of iterative thing which keeps track of. Yeah. It's going to keep going until it gets to something where the value is greater than a half somehow. The animated wow. There's an emote that only one person has access to. It's not quite true. Well, yeah. I think I've set it up so that other people can use that emote as well. But if you switch 0-dimensional points, my interface says that I have infinitely many 0-dimensional points. So I don't know how much that adds up to. Hard to say really. Like they have a little infinity symbol. Don't screenshot. This is what Twitch tells me that I've got, which is kind of an interesting concept then to say. Well, that's sort of a description of the real line, that the real line contains sort of infinitely many 0-dimensional points, but not a great description of the real line. So I don't totally know what to do with that information. Right, okay. 20 minutes of terrible Desmos? Let's do 20 minutes of terrible Desmos. That seems like a good idea. So 20 minutes of terrible Desmos. What's this going to be? Birthday thing. So I've just seen some case-based stuff where, what do I want? I want to say if the value. So my tracking, one of my arguments could be the probability so far, and the other one could be how many we've had or something. So then my function of probability and syntax, probability and number of iterations is something like, if the probability is greater than 0.5 or less than 0.5 perhaps, then just shout n at me. Colons here? Yeah, and then a comma, great. Otherwise, just shout 1 for now and we'll see what happens. Okay, so it's shouting n at me because this is small, and if I do that, it shouts 1 instead. Okay, so then instead of shouting 1, I want it to do some work. Probability is not there yet, so I want it to call f, where the probability is now this times, what is this then? Something like 1 minus n over 365 to make the probability smaller. and your count is now up by 1. That seems like it works. No? Happy? Not happy? Seems vaguely happy. And then we call it with function 1 in here, and n is 0 or something. Ah, and it says 23. Cool, good, okay. We do that. Oh no, I want that to be a number as well. So I've got my probability in here. Okay, so I've got Desmos to do the calculation now because it's running this bit of the, it's doing a nested, it's doing a conditional thing to say if the probability is less than 5, then I want you to just report the value of n that you're holding, which might be 0. Otherwise do this and add 1 to the count. But so I wanted to plot this for different values of 365, which perhaps means that I need a kind of argument here to put the value 365 through the function. Can you even do that? Is it going to let me? Let's put it in here. Obviously I want it here for the number, but I've also got to put it here as another input. There we go. Input, good. So now I can set this to x instead. Oh dear. There's such a thing as maximum recursion depth apparently, and we've hit it. Good, right, okay, there's a graph of it slowly increasing as you look at different things. I kind of only want this on the whole numbers, otherwise it's really doing something quite strange. It's slowly stepping up how many people need to come to this party before there's a 0.5 probability of having two of the same. So 365 is out here somewhere in 23 territory, and then there's more. And the observation is maybe for large values on this graph, it's going up like a kind of square root graph. So how do I want to plot that? I would like to look at this on a log chart, I think. This is good. Desmos is doing great. Desmos is doing really well. So I should probably have stayed in Python, shouldn't I? How do you set the graphs to logarithmic? There we go. There we go, that's nice. Okay, welcome to log charts, by the way. They come with this nice kind of almost tartan pattern to them of different stripes and squares. The idea here, if you haven't seen one of these before, is that they go 1, 10, 100, 1000, 10 to the 4, 10 to the 5 to let you look at very large numbers at the same time as looking at reasonably sized numbers. And up here it goes 10, 100, 1000, 10 to the 4, 10 to the 5. So then, yeah, probably, yeah. So then power laws, because of logarithms, power laws turn into straight lines. So for example, x to the 1/2, there it is. Good. It's a nice parallel line, right? Whereas if you don't have logarithmic graphs, then these things are both just growing to infinity in this kind of curved shape. Taking the log returns those power laws or whatever they are. Blue, some complicated function. Green, just a square root. Yeah, and then I suppose we could do a complicated regression or something, or we could take our largest value, which is something like 10 to the 5, and compare that to a square root. To say, and then just stick that on out the front. Let's just copy paste the number. That seems reasonable enough. There we go, and that kind of looks like it agrees over the top. That's not a line of best fit, that's taking your best data point and making sure it goes through that point on the curve. If we switch off the logarithmic stuff now, see this looks quite good, I think. We've got this stepped stuff going on, so it's not great when the number of days is small, but then over here, much nicer. I think it's sort of getting pretty good. Only a little bit under, isn't it, so far? Still a bit under. Okay, that's interesting, but hey. Yeah, there's a second term of this expansion probably, and it's got a negative sign in it, let's say. Okay, I feel like putting 1.17 in actually, just to have a kind of smaller constant. I feel like there's a statement out there somewhere about what that number is, involving hazy memory, something like pi. It'd be good to know what that number is, wouldn't it? Something like pi over 4 square rooted or something. Not that, that's less than 1. Quick look at the Wikipedia page, I think. Yeah, what is going on here? It's one of those things where I did some reading because it was going to come up at work or something, and then yeah, this one. What is this? Number of days available. This probability is like e to the minus n squared over 2d or something. Which probability are we talking about right now? Oh my goodness. I don't like this argument. That is rather nice. Is this number of people? Probability of a pair. Yeah, that's a very good graph. I like that a lot. But that's not telling me when it gets to 0.5. So I want to know when is this 0.5. I've skipped all this derivation of what's going on. And jumped down to this bit that I vaguely remember, for it to be e to the minus n squared over 2d. Right, back into... I've got so many tabs open now. That won't be helping Desmos. My square root intuition or something. 2d? Yeah. Is something like this. Not pi then, but log 2. So then multiply it by 2, take the square root. I don't know why I'm writing at such a terrible angle. I'm sorry, everyone. Square root d times, and then root 2 log 2. Not that one. Different Desmos window. I've now got too many Desmos windows. Quick stack. What have I got? Yeah, about that number, isn't it? About that number. Let's put that in. It will look clever. Pretty good agreement. Root log 4. I love maths. Maths is great. What's that constant? It's about square root of log 4. Because of exponentials or something. Let's realise that I should have checked what that actually came from. What is going on? Oh my goodness, we're approximating these fractions. This is brilliant. Approximating all these terms that we've got, 1 minus thing over 365, by an exponential. Bit surprising you can get away with that. Yeah, okay, fair enough, because this is small. Yeah. And then they multiply, exponentials multiply together nicely. Arithmetic sequence upstairs. Yeah. It's a shame I've put this on stream now. This would make quite a fun interview question. Oh dear. Can't use this for work. Talks about it on Twitch. No, look, it's good. You have all these brackets that you want to multiply together in the birthday problem. You approximate them with exponentials. Great times. Oh, the fun that we had. This will help me out with the twins version as well, because I can do a similar trick with twins. Ah, yes, I can. Thanks for the follow. Now, there's loads of places I could put spaces in your name, I'm afraid. I'm just going to go for all in one syllable, no spaces, which is going to be like this. I really missed the T's in the middle. Oh, I'm so sorry, John. Right. I'm so sorry. I'm so sorry. Right. Okay, thanks for the follow. Sorry for what I just did. Good. Let's try and do the approximations. The timing was perfect as well. Just as I fully embraced making some sort of Cthulhu noise. Right, good, okay. Let's go back to the twins thing, where we have the twins in here. Oh, but different terms, because the denominator's changing. Maybe that will stop me from doing an exponential trick. Maybe. The idea we've just seen on Wikipedia that I now want to use everywhere is that if you have 1 minus small fraction, loads of them multiply together, consider replacing them with exponentials because they multiply together nicely. Right. Let's see. Can I still get away with this? I'm going to vote for no. I can't get away from this. I would need to add together a whole bunch of terms. So adding together these things is not too bad as an arithmetic sequence. Adding these terms, is it even worth the approximation? Is it even worth the approximation? N people minus I. N people minus I. Can I add them? Not with that attitude. Sorry, stupid thing to write down, but I'm going to write out some of these terms and think about whether or not I can add them. I swear that after the break I'm going to rearrange my tabs. We tried to take a break at 3 o'clock briefly. Look, Miro fixed this thing. I can now deselect the... For about a month you've had to have this open while you're using a pen, and then they re-enabled the ability to close it. Technology. They have not fixed the thing where you used to be able to double tap this to go to 100%, whereas now it just opens and closes a new menu they've invented. Miro. Right, okay. I've completely forgotten what I was doing. Oh yes, I had fractions like this, and I was wondering, is there some sort of, I don't know, partial fractions trick or some way to add these together? The obvious one is to just say that, if I'm adding up like 23 of them, well, the obvious one is to just say that this is a bit like, if we think that 23 is much less than n, two less than signs because it's much less than n, then you kind of can just add them together by pretending the denominators are the same. Yeah, it's not nice, but you can do it. So then, what do we have in our twins bit? In our Python code, or somewhere else on this Miro board, we've got something where everyone's a twin, and as they arrive at your party, you ask them, are you a twin with anyone already at this party? And we ask them, do you happen to share a birthday with anyone at this party? Which is a separate question. Obviously, one implies the other, but I think the probabilities we've written down all make sense. Sort of thing I should go and worry about afterwards. Yeah, okay. What we've actually got is a whole bunch of terms like this with 1 minus I over n days, and these ones I'm treating a little bit like they say 1 over I minus n people. It's slightly more subtle for the twins because the pool of people available, yeah, you're drawing from a finite amount of people in that situation, which is going down. But if you treat those about the same, then you'll get something like, so if you go to 23 or something, so if you pick n people, just lowercase n, then the intuition that you got from that argument I just saw on Wikipedia is something like, well, sum of the first numbers is about n squared over 2, it's n plus 1 over 2, and they're all divided by d for the number of days, and there's a minus sign, e to the minus that. And my new intuition is going to be something like, you also have this other race going on, which is like this for the number of people as you're out there looking for twins. I have used an AI image generator to try to create geometric shapes. I wanted to find out if the AI image generator could do very precise things where there's only really one right answer. Like if you ask it for a hexagon, has it worked out what those are? And no, I won't accept some sort of blobby mess. And the results that I got out when I tried this a couple of years ago, it's weird that it's already a couple of years ago, but a couple of years ago, were interesting wallpapery sort of stuff, which maybe contained some shapes if you really wanted it to. If you looked at it and thought, yeah, this could be geometric, it didn't give me kind of black and white picture of hexagon, which is what I wanted. And of course I can make that using other computer programs, like ones for creating vector art. It's a bit like, this was back in the time when ChatGPT was quite good at writing text, but really terrible at calculation. It felt a bit like AI was going to be good at tasks where there's lots of correct answers, and it can land in the ballpark, but not good at tasks where there's a specific answer. What's 25 times 49 has really only got one. We're only looking for one correct answer there. Show me a dog. Loads of things you can do for that. And then as time went on, I've been showing more and more examples of AI doing very specific things for which there is a correct answer, and getting better at that sort of thing. So that's been fun to watch. AI has convinced John that spheres are actually a sort of pyramid. It's a circle-based pyramid, a cone. Circle-based pyramid. And no, that's someone wearing a hat. They've come to my birthday party. If it's my birthday party, then it's already somebody's birthday. I guess we're still looking for someone sharing a birthday. Right. Yeah. Shapes mentioned. Here comes the topology. I think I was building towards the sort of punchline, but I seem to have lost my thread a little bit. Oh yes, it's going to be something like, these are going to add together in an interesting way. This is the probability that they're all different is something like this, where n is the number of people you're picking from, I think, roughly speaking. I've got all sorts of out by one approximations and errors going on. Some of them are errors, some of them are approximations. So then the punchline is going to be something like, you want this to be roughly 0.5, and previously we would rearrange this and do a square root. I can still do a bit of that. No, not 0.5, I've messed up this log. This is the thing that's log 2. I can still do a bit of that square rooting, but now we're going to get the kind of quadratic mean or something fun, aren't we? Some sort of harmonic mean thing going on here, which is rather worth waiting for, I think. Let's give it a second to settle down. So what will this be? There's the log 4 upstairs again, multiply by 2, take a square root, but in between divide by all of this nonsense to get something like 1 over d plus 1 over n square rooted. That's an interesting construct, isn't it? So if n is very large, you'll never see the twin thing. If d is very large, you'll never see the days thing. It's still giving me vibes of square root number of something. Yeah, let's simplify this. So I can write this as n plus d over nd, and then bring the nd upstairs. So root log 4, which has appeared a couple of times like a sort of mascot. Okay, so there's your kind of crossover behavior then. If d and n are about the same, then this gives, some sort of factor. If d and n are about the same, then this just gives you a factor of, Mary's trying to do t, this just gives you a factor of root 2 underneath, which would be an amazing, it just divides it by root 2. If these are equal, there's a factor of 2 down here, and it cancels with one of these upstairs, so that's good. So that's quite good. If you have two sorts of birthday paradox thing going on. Yeah. So people arrive at your party, I'm going to type this up here. No. We're going to do T in a second, but here's a sort of version of the problem that I think is good. So we're going to type it up and then go and have a tea break and think about whether we've actually solved it or not. So no twins anymore. People are arriving at a party. I ask each of them when their birthday is. There we go. Found the button. Marius redeemed tea time, which means that in a second we're all going to go for a break to have a cup of tea. That includes people watching. I'll ask each of them when their birthday is and what their favourite colour is from a grid, from a sort of a choice of 365 colours. So there's a race going on. Either I'm going to find two people with the same birthday, or I'm going to find two people RFL, two people with the same favourite colour. How many people until there's must arrive until there's a 50% chance I either have two people with the same birthday, which I'm assuming are independently distributed or something, or two people with the same favourite colour. And again, I'm assuming that favourite colour is distributed uniformly across my 365 different options. And I think the kind of back of the envelope reasoning up here is that it should be something like the birthday problem you've heard of divided by root 2, which would then be about 23 divided by about 1.4, which, as we all know, using my favourite programming language, is about 16. So we'll see if that's true after the break. I've done a cliffhanger. There we go. I've done a cliffhanger. Brilliant! I've never done a reason to come back after the break. Have I? I don't think I have. I'm very pleased with myself. Look at this guy. The idea being that we can pair them up because they're either, wow, you have the same birthday, or, wow, out of all of these crazy, my incredible colour chart, you picked the same one. What a party starter. And so I have two ways to go and start a conversation now, birthdays or colours. Right. And then Herb is going to ask what people's favourite colour is or would be. We've previously discussed. I got to choose some colours for the thing you're watching now. Right, speaking of break time, I'm going to go make a cup of tea and I'll see you back in a minute and a half. You might see an advert during this bit. If you do, you're supporting charity, but only a tiny bit. So if that matters to you, there are other ways to support charity too. But this is weirdly one of them. Let's do it. See you in a second with a cup of tea. Bye. think I'm back. I look like I'm back. Here we are. Good. What are we doing? We've got a problem on the screen, and this one is easier to code. Oh, what did I miss? Shades of blue, shades of red, shades of green. Favourite colours have been going on in chat. So we've made a bunch of approximations in my back of the envelope thing. We should maybe get Desmos in on this kind of square root 2 thing. Hello, Pen Centre. Welcome to chat. What does that mean? Ooh, September. I like your badge. Right, good. Oh, what's my favourite colour? Blue. I wear a lot of blue at work because I bought a lot of smart shirts and then realised they were all blue. It's this shade of blue that I like the most, I think, but varies a bit. The kind of background one, the bright blue thing. I have that in that colour's made it into my thesis. All of the fluid dynamics diagrams are coloured in the same shade of blue, which I picked at random. But there you are, some sort of electric thing. I like that. Good, right, okay, I've got T. I've got a problem to solve, and sort of want to try it in Python first. This would be easy, wouldn't it? I would set these to be, so without that approximation, without this term, so forgetting the twins thing for a bit. Don't really know a good way to do this in Python, so I'm just going to sort of do it a clumsy way, which is to comment out that line and do something like this to say, okay, if there are two things going on with a kind of 365 days sort of thing and 365 colours, then you should have some sort of countdown going on how many people's birthdays you've got so far, and also how many people's favourite colours you've got. Maybe I'll call that N colours just to be, let's keep it British, just to make it clearer what's going on. I've got these kind of two competing races. I just want two things to happen. And the idea is that maybe for large values, this might be the same thing kind of divided by square root 2. So we think maybe this will come back as 16 or something. There's a 16 on screen, which is pretty convincing. 17. I'll take 17. Pen Centre's got a coffee, which is of course acceptable. It should be just to be clear, when someone redeems the "it's tea time" thing in chat, I go and make a cup of tea. You're encouraged to make a drink. Oh, you're doing linear algebra. Tell me more. What are you up to? Lots of ways that could go. I'm going to check a few more numbers in here, I think, to see what happens as this scales to larger numbers, and then I might give it to Desmos, because I think in Desmos it just involves squaring a term in the Desmos implementation we made. So it goes to 27, and then two more zeros goes to 264, two more zeros, it increases to 2634. So this really feels like it's doing the multiply by 10 each time I multiply this by 100, which is what I wanted. And so question, is it this divided by 1.4? Yeah, more or less. Maybe not quite 1.4, but I was never really sure this was 1.1. See, that's not too bad. That's not too bad as a first approximation, is it? Ooh, change bases. Hang on, I wasn't keeping up with chat. I've got three things going on, it's great. One of them is a cup of tea. Organising a reading group, matching up YouTube lectures. Oh, that's good. Matching up YouTube lectures to the chapters of the textbook. That's a sort of helpful resource. Sounds good. Right. Okay, so this divide by 1.4 thing seems to work well if you have, well, really quite a lot going on here. Let's put that down to 365, think a little bit more. So I was a bit let down by this 1716 switch. I suppose, what did I do? I just took the previous number, which was already an approximation of this much stuff, and I divided it by 1.4. Then, well, I suppose I can do better than that, can't I? I can do maths dot square root 2. I mean, is that better? That's made it a smaller number. So, swings and roundabouts, right? Some values of better. I should probably bring these all inside, shouldn't I? So it should be maybe log 4. Oh, look at this. Log 4. Do that, and then divide by 2. And then I don't have to put so many square roots around. Yeah, there we go. That's a bit better. We get there in the end. Yeah, that's not too bad. Not too bad. Let's me write 2 instead of 1.4 or square root 2. Oh well, never mind. Okay. Is the natural thing to ask about? So yeah, so we had this kind of competing thing going on where if you've got more or less of these, then the correct way to replace this n days is something like inside the square root, is something like to replace that with n days times n colours with a U, because British spelling. For those who have just joined us, we've committed to writing our Python code with British spelling, which is not going that well. And now it's going to give me an error for saying such a very long. No, that's so drop the factor of root 2. Good, okay. Oh, is that actually slightly closer? Yeah, 500. Right, okay. So this should now, hopefully these two numbers should stay similar to show this is a good approximation or something. As I change that to do something similar to what we were doing before with these two competing processes, to show you how if this thing is enormous, then it doesn't matter. We end up being close to 23 or 22, annoyingly, in my approximation. But as it comes down, it sort of suddenly takes over, so that this is the important race, which is saying that it'll be done in a really short amount of time because this number is so small. Whereas on the other hand, if I change the other one, well, they're playing identical roles. I'm sort of ignoring the linear algebra coffee extended joke, but this is me acknowledging that it's there, so that's good. In Desmos, I reckon. Oh, I said I was going to sort out my tabs and then I didn't. Right, let's just compile them all together. That's a good idea, isn't it? There we go. I got my Wikipedia thing, which says, and this is the advice of the day, I think, if you have a fraction that's close to 1, why not rewrite it as an exponential? Fun! Now you can multiply them easily. Great stuff. For the birthday problem, this converts your complicated line in black in this chart into this approximation with this red line where exponentials are easy to multiply. And that's not perfect, but that's not bad. And that's just such a weird gimmick that I love it so much. There are little bits of Wikipedia where somebody, sometimes anonymously, has added half a sentence that just contains so much joy, so much ridiculous maths fact kind of thing that's just been totally buried on Wikipedia. I think buried somewhere on possibly the Wikipedia page for the number 1. There's this mad reciprocals of the powers fact that it's the sort of thing you could just go past it on Wikipedia, or you can stop and look at it and say, somebody's added this fact, this sort of fun maths fact. What are they talking about? And what on earth is going on there? It's great stuff. Oh yeah, the Penn Centre's just found out by me closing a tab that there are complex numbers in Desmos. Penn Centre might be interested in this thing made by Maths22222 in chat. It's now really, really easy to do the Mandelbrot set in Desmos. Sips tea. But that's none of my business. I've got. It's so good. Look at this. Right. What was I going to do? Oh yeah, I was going to put a squared in here and see if that just divides things by 2. Yeah, it's a Taylor series fact, the exponential trick, but not a Taylor series fact I would have thought of using. If you phrase it in terms of the exponential function could be approximated with its Taylor series, that way around makes sense to me. If you say the Taylor series, the first two terms of the Taylor series, can be approximated by the exponential, that feels weird. to take sort of the fraction or whatever for x, a small number, and say I'm going to replace that with e to the minus x or something. It's just like, what are you doing? What sort of maths is this where you take something nice and you replaced it with exponentials? You get some multiplication. Right. As this works out, I think this has sort of worked out. Those things look pretty similar. Of course, this live stream does not deal in pretty similar. It deals in the same, for which I would like to switch my graphs to logarithmic again. Yeah, that's the good stuff. There we go. So just putting the squared up here has turned into just a factor of √2 down here. Is this generically true? No, probably not, but there's maybe something to look into, right? To say, if you've got two identical distributions, what's the distribution of the minimum? This is a 3 Blue 1 Brown Matt Parker collaboration in a recent video, isn't it? The distribution of the minimum is something like the distribution of the square root or something, or maybe it's maximum and square root or something. I've seen that before. We've got, yeah, we've hit maximum recursion depth. Yes, did you? Excellent. Good. Look, chat's just hitting so many jokes simultaneously now. It's brilliant. Love it. Yeah, I am asking it to do quite a lot of recursion depth, especially over here, I think. Over here. Let's switch that back. A plus over this equation. Whoever added this to Wikipedia should be very pleased. Well, just like the whole argument, I suppose, but this sort of. They explain it in terms of the Taylor series, but then say, hey, look here, this probability, which was all these multiplying fractions. Okay, right. General question, I think. Let's see if I can turn this into an actual probability question or something. General question. If you've got two identical, they're not, this is not quite the Matt Parker 3 Blue 1 Brown video, because they did their video about uniformly distributed distributions. I would like to think about the general problem, for which there isn't a nice answer, but you know. Two identical distributions. I guess they're taking values in the positive naturals. Maybe I want 0. Yeah, no, I want n. How can I find the distribution for, let's give them names. The minimum. And I think it's something like consider the generating function or something. Yeah, so it's going to be, so let's give that thing a name. Independent. Maybe this is the sort of thing you can talk about, because the probability that Z is greater than, which way around is this? Probability that the Z is greater than some value is the probability that the minimum of x1 and x2 is greater than that value, which is the probability that both of them are greater than that value, which is because they're independent. This might not be true. I can't remember how probability works. Is this how probability works? 2 question marks. Oh, I've got a black bar on the left of the screen. Oh, I know why I've done that. Okay. Professional stream. There we go. Something like this. So then take probability distribution function or something, square it, see what happens. Oh, so I can get rid of some refinement on Desmos, thank you. That'll make it happier. Oh, it's happy. It was unhappy down here. So one that would never hit 1. Right, some weird stuff going on. Thank you. Look, see? Maths Tutor 2 is debugging my Desmos code for me. Citation Black and Pen Center trading Google shortcuts or in-jokes or something. No one's teaching me how probability works, so I'm going to have to keep going. It's sort of like, what do I think? How do I think minimum works in the x1, x2 space? Minimum is like rolling with disadvantage. Probability that the minimum is 3. So the minimum being 3 would be you're somewhere along this region. That doesn't tell me anything about. Yeah, okay. So this is this thing I've been doing about having both of them greater than something. Yeah, okay. So if you've got some probability distribution function, square it or something. And is this where the exponential distribution comes in? Because then if you raise these things, the exponentials will multiply together or something. Exponential race feels like a phrase I've heard in probability. Let's learn probability together. Oh, maybe let's not. Maybe let's not. How does the exponential distribution work in stats? Yes, this one. This one. How does this work though? Remind me exactly what that is. Am I supposed to integrate it or not? How does it work? I can't remember. Brilliant, you're supposed to integrate it. If you integrate an exponential, you're okay. You get another exponential, and the parameters will add together. So then, yeah. Oh, that's what I want. That's the thing I want. CDF, not the PDF. Cumulative distribution function. It's been a long time since I learned statistics. Sort of getting the feeling that no one in chat wants to learn statistics today, but here we are. The cumulative distribution function for this particular distribution is 1 minus e to the minus lambda x. So if I had 2 of these and I was multiplying them together, then the lambdas would just behave nicely. Yeah. Maybe Desmos can do stats. There's so much to learn about. I should maybe read the docs or something to find out what Desmos can do. I can't remember how to do the metronome thing or any stats. I remember this one being memoryless, but not what that means. So I'm going to quickly hover over the word memoryless to jog my memory. Maybe I'm memoryless. The time already spent waiting for an event, oh, yeah, okay, does not affect how much longer the wait will be. Right, okay, Px greater than C given x greater than D or something. Goodness me. was there all along. Thank you. Ooh. Can't remember how this works. It's like this, isn't it? It's gone. So you can make your own sort of things that animate or move around. Nice. I can choose where it is and then fire it off to the right. You can do a lot with this, can't you? Yeah, okay. Yep, I remember why I wanted this. Thanks. Okay, bored of this now. Birthdays, twins. I did wonder if there's some version of this where you don't have very many twins. Maybe we've thought about a version where everyone is a twin. There are loads of twins. And then I've thought about a version where... Well, the original version, no one's a twin. So is there an in-between version where some people are twins? I wonder. The in-between version would be something like, well, roughly 1% of the people in the world are twins, or something like that. Not true of our viewership right now, but roughly 1% of the people in the world are twins. But if only 1% of the people in the world are twins, then it's not going to come up, is it? Because there's a tiny probability that for your 23 people in the birthday paradox or something, that you've even got one person who's a twin. 23%. And then that's not actually true, is it? Because I should be doing 99%. Is it 1%? We'll look that up in a second. But hang on a minute, what's 99% to the power of... What's the probability that they're all not twins? Maybe that's surprisingly small as well. Let's use a calculator for that. So if there's a 1% twin rate or something, then if you have 23 of those, there's still 80% that you haven't found a twin yet. Much less that you've found, much less that you've then also found their twin out of some large population or something. If you've got 100 people in the room and there's only one pair of twins, they're probably neither of them are going to come into this. Maybe. Hang on, let's think. So, but if that was 6% or something, if that was 6%, would that be interesting? Yeah. So if that's 6%, then you're quite likely to have found a twin, and then I just need to believe that you might have found a second. If the room size is about 300 people. 2% to 4%. Okay, thank you for looking it up. I will take 4% and see what I can do with that. Yeah, not impossible that you found a twin. So the scenario then, you've got to be really careful describing the event because that matters quite a lot in probability. But the scenario is something like, maybe, let's say you've got a room with about 300 people in. You're doing a maths presentation, magic trick kind of thing. You've got a room with about 300 people, and if there's a twin, then their twin has attended as well. So for each twin in the room, which might be about 4% of them, their twin has attended as well. Now that might not sound like it matters, but I wonder if it's enough to bring down the answer to the birthday problem from 23 to 22, because just occasionally you're going to get both twins. Or there are 8 of them in the room, I suppose, or something like that. So you're going to get two of the people who are twins. Some small probability that you get both. Okay. Yeah, so let's try and draw a diagram of this. I'm going to use 4% because that seems interesting. I would like the answer to this I know what answer I want. I want the answer to be... Birthday Paradox says that the number is 23, but if you stand up on a stage in front of 100 people, then because there might be some twins, the answer is more like 22. That would be nice. You have to assume that they've brought the twin, otherwise, what's the point? You have to assume that. What's the point for the trick, right? The state of having a twin who's not here. That's not going to bring my number down. So, what if you've got something like 300 people? Now, is Herb's range of 2% to 4% because twins come in pairs? Is that why it's a 2% to 4% range? Is everyone in my Twitch chat a twin? What is going on? What is this? Okay, right. I've finally found some relatable content. Let's say 12 are twins. Oh, okay. Urban Pen Centre are not twins. The funnier thing would be if you long lost twins for each other, perhaps. Not that we know of yet. Let's say 12 are twins. Is that maybe what the 4% means? Maybe that's what 4% means. 4 out of every 100 are twins. You do the birthday paradox thing to the twins. You might get 2 of the twins. Maybe. What are the odds? What are the odds? Okay, there you go. There you go. Sure, yeah. So, okay, the maths tutor do make. Yeah, good point. We could do. If I need this number to be larger, then I can make an argument for that. Okay, so this is going to be maybe totally new Python code or something. What am I actually avoiding? It's something like... With 300, it's quite tempting to do it like a little simulation or something, to start doing random numbers and actually choose people, like we were doing for the choosing random cards games that we were playing over the last few streams. Actually, a while ago now, we were doing random cards, random numbers, see if you get 2 in a row. That's kind of what we're doing here. Oh gosh, is it actually the same? No, not quite, because 2 in a row is not the same concept as being twins. You're 2 in a row with 2 different... 2 in a row is a slightly different concept to being twins. Right. Yeah, I think that me learning only MATLAB and Desmos was quite an aggressive position to have taken. But currently those are the main things I speak. Part of my aim here is to learn an actual language. So maybe I should learn a random bit of Python. How do I do that? Let's start a new, I don't know what they're called, but a new one of these or something. This is going to be embarrassing. Let's go in here and go like new Python file. Yes, please. I have to give it a name. This is going to be twins. Okay, great. So what do I want? I want something like some ability to select a random element from... Am I going to do this random simulation? Am I going to do it? Let's read what's in random. Right, let's just import random. How bad can it be? Docs. Random.choice. random.choice. So let's go x's range 300 or something for my 300 people. So let's go. Let's call them people. And then apparently you go random.choice people to get a random person. Let's just print that and see what happens. So this will give me person 42, a randomly selected number. Just the right number, I think. Thank you, random.choice. Yeah, import random.choice. Thank you. 169, 86, 83, 220. Brilliant stuff. I should probably also pop them to stop them turning up twice. I think I know how to do that, but I'm not sure. Is it something like, can I go for my, what does range actually return? Does range return a tuple or a list? Hello, nstucky. We're learning Python very slowly. Can I do this? Is this allowed? Is this a thing? No, not at all. Rubbish. Completely terrible. We're going to really quickly learn this. Oh, it's called remove, maybe. Is that how you do it? No. Oh my goodness, what is it? It's a range object. Oh, is there a special range? Oh no. Random.sample might help. Okay, right, let's learn about random.sample. What does random.sample do? Let's see how fast I can learn Python just by having W3 Schools open on my left monitor, chat on my right monitor, Python in the middle. Oh my goodness. Returns a list with a specified number of randomly selected. Oh, that's much better, isn't it? Yeah, I think I want that, don't I? Random sample. Convert it to a list. Okay, yeah, good. Yeah, type conversion, hooray! Is this going to work? Is this going to remove 42? It's going to be happy, good. Okay, so this is like my new person. I want to remove the new person. It's not very happy with this. What's the green squiggle mean? Oh, type it. No, it can't be bothered. Good. Here we go. This is perfect. We've popped someone off the list at random. No, I'm not doing the walrus thing. I've heard of the walrus thing. I'm not doing it. I don't really want to print at the same time. I will take your suggestion of just renaming this to the letter A, which is the thing that I always want to do. Okay, so this is sort of pick one. And we're going to wrap this up in a sort of while loop, maybe? No, I can't be bothered to do it. Let's go for I in range 300. I'd like you to do the following stuff, which is to pick one of them, remove them from the list. This is so stupid. This is maybe the stupidest code stupidest code I've written today. Because now I'm probably going to do some sort of stupid pop them into a different list. Yeah, I shouldn't be popping them off the list at all. I should keep them in a list, but I should shuffle the list, which I think is a random. I think there's a random shuffle method. There is a random shuffle. Perfect. I don't really want to pop them out of the structure. I just want random shuffle people. Randomly shuffle people, because now they're just. I can now just pull them out of the list one at a time and see how long it is until we find a match. Yeah, something like that. Yeah, I've got my 300 people, they're all shuffled up. And we're going to go to see if we can go. So we're going to look with something to do with pairs, isn't it? So we're going to look, but not all the way to the matching one. We're going to say something like, oh, this is so stupid. I should have assigned them birthdays as well. I should assign them all birthdays. This is almost like simulating a population, right? I've got my list of people, but I really want their birthdays as well. Oh my goodness! Right, time to generate some birthday data. Oh, I'm not creating my own class. I do not know how that works. Feels wrong. I'm gonna have a separate list of birthdays, which is gonna be a list, and it's gonna work like this. We need some random numbers, don't we? We need random rand int. So from the random library, is there a rand int function? There is. Talk about method in random.randint. And it's got a range. I would like a whole vector of these, please. Oh no. Oh no. Am I going to have to write a loop to assign a birthday to each person? Oh no. So I can do one person's birthday with random.randint. I have no idea how to do a loop of these things. I'm out of my depth. This is going badly. What do you do when you're out of depth? Keep swimming. Something like... I would quite like... This is a trick that I use all the time in MATLAB, so I'm just going to do that. And then I'm going to go... This is perfect. Yeah. Yeah, something like for I in... You see, I'm so sort of MATLAB brain that I want to keep doing all my I loops, looping over integers and slowly accessing things by their index, rather than doing what MathStudio is saying in chat and looping over the objects or the people or something. This is just so MATLAB-ish and not Python-y at all. You know. Wait, what? You can just wrap it in square brackets and it'll do a vector? With a for loop in the middle of a line? I'm never going to learn Python. This is nuts. Yeah, alright, let's give it a go. Let's give it a go. Let's just run Python code from chat. That seems like how this... It just does list comprehensions. Oh, and I should probably give it some range, right? I would like these to be between 1 and 364. 0 and 364 or something. Oh, is this like the situation where I have to put the largest integer I don't want or something? I've been out by one so much for the entire last live stream. Like all these almost 2 hours of doing things. Yeah. It starts optional. Starts required. This looks great. I don't know what the green thing does, but you know, there we go. Yes, I've indented some stuff over here because I haven't finished writing this code yet or something. Let's just comment that out for now. Are we having fun? I think we're having fun. Yes, good. Okay, we've shuffled all the people now. For I and range this. Should we print out the people and their birthdays? Oh, this is not good because I'm accessing these really slowly or something. So let's go person in people is the Python way of doing this, isn't it? Because then I can print the person. Can't print their birthday though because I don't have an index anymore. Take herb. Oh my goodness. Maybe I should have made a class. Because then I wouldn't have to write nonsense like this, would I? This will be noisy. Something like this. It's going to give me a big string of people and birthdays, including, oh, that person's birthday is on New Year's Eve. That's fun. Okay, that looks like it could be a list of the sort of stuff I want. Too as good as a class most of the time. When I was much younger, I wrote some code that had... I didn't know about arrays, or I couldn't get arrays to work in the thing I was working on, but I did have a long list. So, and I had several properties. I had these sort of bouncing billiard balls. So I wrote a very long list to store all of the positions, velocities, and colours of the of the billiards balls as they were moving around the screen, so a very long list which I accessed very, very carefully. But debugging this was a nightmare because occasionally two of the balls would hit each other and just carry on moving but change colours, because I was updating not their velocities but updating a different bit of my very long vector, which had their colours stored in it. I feel like maybe just me, but you start out with, why not just store all of your variables in one very, very long list, which you call A. You call it A because that's the first letter, and you don't need a second letter because all your variables are in A. You start there, and then you build up to... to be building up to my first Python code. Great stream content. This is what the people want. Okay. We're going to write some ridiculous Python code now because we're going to try and check whether these people have the same birthday as someone who's previously come in. We're going to imagine that we've got, as I is increasing, people are arriving. I'll write a note there. As I is increasing, people are arriving, and we're going to say, well, hang on a minute, for j in range up to not quite you yourself, is it true that you have the same birthday? Do I put two equal signs here? If you have the same birthday as somebody who's already here, then I would like you to print birthday snap, and I would like you to, just to confirm it for me, birthdays and also birthday. I think I could probably do this with commas, can't I? But I like the idea of doing new lines, and I'd also like you to sort of break a bunch, just call it a day. That'll happen at some point, won't it? Maybe we should up this a little bit, like this. Okay, right, so we've hit birthday snap, but quite a lot of times. Why have I hit birthday snap so much? I'd sort of like to break and just completely stop the loop. So many birthday snaps. Part of this is that you get lots of these. Yeah, I should use F strings for when they're matching up. Great suggestion. There's all these like Python features that I haven't learned yet and sort of refuse to, but there we are. So break doesn't get me out of this because I'm not in a function. What do I want then? I want to sort of stop. How do I stop? This is a control thing, isn't it? Yes, break out of... How can I break out of multiple loops? We should not be doing this. It's the key take home from a quick Google search of the thing I would like to do. The main sentiment of the thing I'm doing is to not do this. Yeah, it really is a function, isn't it? I just want it. I want it to stop all computation and tell me a number. That's really a function. So this should just be wrapped in a def thing, I think. And it's a sort of 50% stop or something. So it's a. It sort of defines like a half chance thing or something. Def match found or something. It's a function with no inputs or something. It's a function with some inputs. All of that should probably be inside here. So I sort of want this to return I and just stop talking to me. So then it won't return anything at all, obviously, because I'm not calling match found. I'm not telling it to do anything anymore. And now it's unhappy with me because you're supposed to declare the function first and then call it afterwards. So now it's saying birthday snap 64 and it's returned this. It's not doing anything with the number down here, is it? I'm supposed to print it down here if I actually want the number. And that's sort of how long it took to find 2 people with the same birthday in this case, I think. So get rid of that shouting. Get rid of some of this setup. There we go. So is that going to be a thing where this time it took 7 people arriving? Possibly 8 or 20 or something. And I would like... Oh, this is now quite complicated because my simulation way of doing it doesn't say anything about 50%. It just tells me I found a match. It's not calculating any probabilities. This is giving me something like... What I could do is run this lots of times and add up how often it's less than 23. Or whatever. Yeah, you take lots of samples of this and then you count separately afterwards. You count in how many of the cases was it less than 23, 24, less than 25. And you find out which one of those matches up with 0.5. For which n is it true? You've got a separate search to do to sort of invert the function and work out where the median of the distribution is. Because at the moment we've just got samples of how long it took. I can't really remember what I'm doing. Oh yeah, separate variable or something, separate list of whether they're twins or not, to see if that brings down the average. Yeah, I don't really care about this 50-50 thing, do I? I care about the sort of average. What is the average? We can answer questions like that now, because before we were just working out when you hit the median. We did not have any sense of what the average was. It's a distribution like this or something where it's quite sharp, so it's probably about 23 because it can't really be much else. But we now have this ability to do something like n trials is 1,000, and for I in range and trials. So I'm still writing MATLAB code, aren't I, with the I in range? Something like start the total at 0 and do an add-on something like what you see when you do a match found thing, and then we'll do what I want to know is something like that total it's something like the total divided by n trials for some sort of average value. Yeah, which is more like 24, but I think I might be out by 1. So there's a good chance I'm out by 1 in what's going on, like the relationship between the number and these, which I should think about. So let's go somewhere up here. We should have some sort of counter for the number of days, which is like 365. And a good way to check that my code's working is to say something like if there's only 2 birthdays, or even if only 1 birthday that you can have, my code currently says your average, and you need about 2.6 people before you find that match, which seems nonsense. So that's bad. Especially that that's not even an integer. Yeah, sum the match found for iron. Okay, fine. Call it inline. It's a list comprehension thing, and then sum it afterwards. I will learn Python at some point, just by mostly maths222 in chat telling me how to do things in Python. My code's working, sort of, except it's obviously wrong and not working. Because I think my match found thing is failing somehow. I've decided that everyone has the same birthday, and birthdays should all be the same. So as soon as I has 1, this should notice that we've got the same birthday going on. Should always be 2 people. Yes, your way around gets rid of the variable tot, and instead of doing 3 lines, it's 1 line. I get that your way is better. Oh, and probably you've also divided it in lines, so fine. Why is my match found thing taking so long? Not taking so long, but taking, yeah, why is it averaging 2.6? Let's try running it again. Okay, yeah, nonsense, but only 10. I also wanted to print match found a bit again for me, just so I can see it taking, yeah, 2 or 3. Why is it taking 2 or 3 turns? This 2 or 3 on the way around here. What am I doing? Feels like an out by 1 sort of thing. Can I see the birthdays? It's not really returning the birthdays. Let's put that. Yeah, I know it's after the return. I know it's after the return. Right, okay, because their birthdays are either 0 or 1. Because this thing... Wait, what? Why are their birthdays either 0 or 1? I thought randint was going to give me... I thought randint wasn't going to do that. It's giving me the... If end days is 1, I thought it would never give me 1. Okay, let's set that to 0 and see what that does. That's better. That's everyone's got the same birthday and it takes 2. In this case, where everyone's got one of 2 birthdays, okay, so maybe I'm supposed to set that to 364. Now the average is like 21.6 or something, which it's not really because I'm only doing 10 trials and I'm doing loads of shouting. Bit better. Yeah, I'm doing a very slow code, right? What's the suggestion? Adding it to a set and finding when it's already in the other set. Yeah, I thought about that, right? About popping things off and putting them in the other set. Or is that silly? Is that order n? Don't you have to... Finding if it's in the other set feels slow? I guess Python does it with in, doesn't it? So is this sort of... I don't know, but maybe there's a sentence that's something like if bdays are in, and then some sort of slice off this thing up to something like that instead of the loop. Don't know. Feels all right, but let's see if I can make that work. See if I can make this work. If this thing is in the previous, I think that's how you do a slice, to take everything up to not the last one though. Right, now it's saying 0. Yeah, I don't want all the birthdays. I want to go all the way up to the ith birthday, like this. That's better. Okay, give me lots of trials. And now the average is about 23 or 24 or something, which I could totally believe. Good, okay. So I've got this other test that I want to add in, which is about the twins. So something like, I could have a twins vector, couldn't I? Or something, to just sort of do a separate test. I'm pleased that I've managed to get this in. I think I've got the syntax right. You could probably do a lot better. You could probably make this smaller. Yeah, cool, right, okay, I've hit 4 o'clock, which is the time I normally stop. I'm sort of happy we've got an average thing. We don't have any twins in here at the moment, which was my plan for today, but, you know, Can't win them all. Still not happy with this. That's sensible. That's not. Well, maybe that is sensible. Just need to write in that. We already made the big cube. Big cube exists. We made it very quickly. I'm supposed to be covering it in. Item frames, because you can put item frames on any surface. Haven't done that on the stream yet, so I suppose we need to go back and cover the big cube in item frames. We'll do that at some point, I guess. Good, right, okay. Yeah, have people not seen this? We did this. We got the big cube. We've got to go back to the big cube. It's not good yet. There's people in Discord talking about the rate it might take to properly oxidize in Minecraft. But not yet. Okay, right. We're going to come back to... Why is this safe for iron people? That can't be right. Doesn't look good, does it? Local variable I is not used. What was I supposed to do? I was supposed to do something else, maybe. So like, what does this say? Shadow's name I from outer scope. Oh, right, okay. It's warning me that I have an I over here. And that I use I for all of my loops or something. So I should be doing this much better. Good. Okay, right. Take care, everyone. Maybe never Python again. We've had a go at writing terrible Python code. Maybe never again. We'll see you. Yeah, Mary's got time. I think I'm probably live. Oh, am I live next week? I might not be live next week. There's a chance I'm not here like next week for Chill Maths. Might be back in the week after that. This is lining up with a busy bit of my year at work. We will find out if that affects the stream as well. Chill Maths. Right, keeping it chill. Possibly in 2 weeks or something like that, depending on how stuff goes. I'll see you around for more Chill Maths. Enjoy complex numbers in Desmos. And I should check the Discord, see what's going on in there. Right. Take care, everyone. Enjoy the rest of your weekend. Yes, right. Okay. I pressed this one to say back soon. Back soon. Bye.